This is Module 6, Lesson 17. Read the objective while I read it out loud. I can draw symmetric figures using distance and angle measure from the line of symmetry. So we're going to draw things that are symmetric figures using distance and angle measurements from the line of symmetry. To begin with, we're going to start with our fluency practice. We're going to practice with making larger units, which is really what? Reducing. So I want you to try your best and come back and check your work. All right, let's check your work. So 1/2, 2/5, 3/4, 1/3, 3/4, 1/3, 1/3, 1/4, 2/3, 1/2, 1/5, 1/4, 2/3, 1/4, 1/2. All right, hopefully this is getting easier and easier and you're getting faster and faster at that. Our next part of our fluency is to subtract a fraction from a whole. So remember, you have whole numbers and fractions. You're going to use your knowledge of subtracting a fraction from a whole number and come back and check your work. So this is a really good review. All right. Now, I took an approach today that you may not normally use. So what I did is I changed that whole number into a fraction and I simply subtracted. So then, like we've done before when we borrow, I turned that 4 plus 1 is 5, and I made it 5/4, and then I changed this to a new fraction to make them have equivalent denominators, and then subtracted. I took that. I know that 2 is really 8/4 because I knew I had to have a 4 as a denominator. So 8 plus 1 is 9, 9/4. 9/4 subtract 2/4 is 7/4, which is really 1 3/4. Here I took 1 away, add 5, and I added 4 plus 1 is 5/4. And I turned this into a new fraction so that I could subtract, so 5 3/4. Then I took this 1 and I turned it into 6/6. 6 plus 1 is 7. 7/6, subtract 2, 6 is 5/6. I took 1 away from this 2 and I added 6 plus 1 is 7. 7/6 minus 2, 6. I have 1 left, 1 5/6. Here, I took 1 away from 3. I end up with 2. I added 6 plus 1 is 7. 7/6. Subtract 2, 6 is 2 5/6. I took 1 away from 7. Ended up with 6 as my whole number. 6 plus 1 is 7. 7/6. Subtract 2/6. It becomes 6. 5/6. If you need to go back to Math Antics and watch the videos and do the practice problems from how to subtract fractions and whole numbers, go back and do that again. This is a skill that you really need to be good at. I took the 1 away and I added 8 plus 1 is 9, 9/8. 9/8 subtract 9/8 is 0. Took 1 away, 1 is left. 8 plus 1 is 9/8. Subtract 9/8. 9/8 subtract 9/8 is 0. I'm left with 1. I took 1 away from 5 and I'm left with 4. 8 plus 1 is 9/8. I converted this into a fraction that I can subtract. 9/8 subtract 9/8. I'm left with 4 here, so my answer is 4. Then I took 1 away from 9. I'm left with 8. 8 plus 1 is 9/8. Subtract 9/8. My answer is 8. So the Math Antics videos on subtracting fractions with whole numbers would be a great video for you to go back and review if you are not really confident with this. go back and rewatch the video, go back and pull these numbers apart. Remember, you have an extra page back here that you can write notes on. All right, moving to perpendicular lines. If you have a ruler handy or a set square, you can get that out. We're just going to draw some lines, draw some perpendicular lines. So we are going to start out with a perpendicular line that is about 4 inches long. Four inches long. All right, now we are going to label this segment AB. Now we're going to use your ruler to draw a 1 3/4 inch line segment AD that is perpendicular. Perpendicular. I'm going to need my set square to A. So my line has to share So here is going to be D up here. So AD is perpendicular to AB. So we would write that as AD is perpendicular to AB. Right? So, question for you. If this line right here, if AD is 2 and let's see, it's 1, 2, 3, 4, 5, 6, 7, 8. If it's 3/8, 2 3/8, if it's 2 3/8 inches long, what would the length be if we extended D and we made this exactly the same below? What would the length, if I copied this line and put it below, and I made the same line, let's say we named it E, all the way down here. What would the total length of that line be from D to E? Any ideas? Well, if we copied this exact line, and this line measures 2 3/8 inches here, and we picked it up and added it below here, we would be adding 2 3/8 plus 2 3/8, right? Or 2 3/8 times 2. So this would be 4 6/8, and 6/8 can be reduced down to 4 and 2. Wait, take out the 2 and I'm left with 3. 4 3/4 inches long, because we would be doubling it, right? So we would be doubling it. The same thing for over here. What if AB, we picked it up, copied it, and added it over here? How long would if this is 4 inches and I picked it up and copied it, what would the total length of that line be? Well, it'd be 8 inches, right? So I'm kind of leading you into our big idea for today. It's going to be creating those perpendicular lines, but a perpendicular line crosses a line at a perpendicular line, which crosses and creates a 90-degree angle, right? So that is going to be our big idea today. So and you can do that for centimeters. You could do that for millimeters. So even if we drew a line that was 2.5. Let's draw it. Here on this side, this is 2.5 centimeters. Okay, if we drew the exact same line on the other side, it would be plus 2.5 centimeters, right? Which means that my line should measure 5 centimeters, right? Okay, what if I did 1 3/8 centimeters? So we have to count, like, oh, is there eighths in here? 1, 2, 3, 4, 5, 6, 7, 8. So if we did 1, here's 1, and we added 3/8. 1 3/8 plus another 1 3/8, we would just add those up. 1 7/10, right here. 1 7/10 plus 1 7/10, right? All right. So we're going to be using these ideas in today's lesson. So moving on, we have one last thing to talk about. It's our application problem. Now, we practiced with this in the last 2 lessons. So in lesson 14 and 16, we talked about lines, perpendicular lines, and then lines, symmetrical lines, right? Parallel lines by moving our ruler, correct? All right, so here we plotted 10 and 8 and 3 and 3. And we labeled it C and D. So this is line segment C and D. And then we drew a line segment perpendicular to CD. So that's as easy as using a set square to draw that perpendicular line. All right, that will do it for our fluency for this morning. When you come back, have out your extra notes go here page and have out your problem set. So what you're going to do, you're probably going to need either a ruler or a set square. If you really want to get precise, you can use your protractor as well. If you really want to be precise on your angles and making sure. So symmetry, that's what we're going to be talking about when you come back. Make sure you have your problem set ready to go and you have your tools.